so we have a complex number Z1 plotted on our Argand diagram, and we want to find out Z2. So Z2 is made up of 2 times whatever Z1 is. And Z1, we're told in the question, is 2 plus I. So plug that in and work it out now, and you'll get your Z2. You get Z2 to be 2 by 2 is 4, 2 by I is 2I, and Z2 is 4 plus 2I. Common mistakes here. Out to 4, up to 2I. So a common mistake is someone plotting it and forgetting to label. You only get 3 marks out of 5 for doing that. Don't forget to label. The question says plot and label. Moving on, part 2. So it asks me for the complex conjugate of Z1. So Z1 is equal to 2 plus I. So the complex conjugate is, and the easy way to do it is just change the sign of the imaginary part. Imaginary part only, and that's of course, sorry, let me put the little hat indicating we're talking about a conjugate. So your answer there is 2 minus I. In case it ever come up in the exam, I think it did come up last year, remember that the conjugate is a reflection of the complex number in the real axis. So it's a reflection. From here to here is 1, from here to here down is 1. And as I said there, the complex conjugate of Z1, which you're not asked for, is 2 minus I. Okay, so that's just showing that. Now, investigate if the modulus of Z2 is equal to, now actually, first of all, should really work out what is in the brackets. So you've got to work out, first of all here, Z1 plus Z2. So Z1 is 2 plus I. And, sorry, that's the complex conjugate of Z1. What am I saying? Complex conjugate. This is the bit inside the brackets here that I'm working out, first of all. So this bit here. I'm working this out. Z1 plus the complex conjugate of Z1. So the complex conjugate of Z1 is 2 minus I. So when we work this out, we get 2 plus I plus 2 minus I. The i's will cancel, and you're left with 2 and 2 equals 4. And you're asked to find now, so the complex conjugate of Z2, is it equal to the complex conjugate of or the modulus, what I'm saying, the modulus of Z2, is it equal to the modulus of Z1 plus the modulus of Z2? That's what those 2 lines down the side. Plus the complex conjugate of Z2. Jeez, I made a mulligan's mother. So, Z2, what the hell is it? We've got to maybe go and work that fella out as well. We know over here that's just going to be, well, that's 4 plus 0i actually, so that's going to be 4 plus 0i. This is a bit of a messy one here. 4 plus 0i, and this one on the left here, the modulus of Z2. Z2 is 4 plus 2i. So, remember our modulus formula. The real part to be squared plus the imaginary part to be squared. Or, sometimes you might say, the modulus is equal to the square root of a squared plus b squared, where a is the real and b is the imaginary. So, doing that, is that equal to, so we're wondering question mark there in the middle, modulus of the real part to be squared plus the imaginary part to be squared. So, on this one here, the real is 4, the imaginary is 2, the real is 4, the imaginary is 0. So I think you can clearly see there that you're going to get 16 plus 4 is 20. That's going to be, you're going to get 2 root 5, I think, on that side, and that's not going to be equal to the square root of 16, which is 4. So basically, that means that the modulus of Z2, writing them down wrong, is not equal to, so the distance from the origin to Z2 is not equal to this one over here. Okay, moving on then, number 3, show that it's a root. So, I suppose, giving you just a background here, 8x squared plus 8x plus 15. We know here that x equals x equals minus 3 is the solution. Okay, so what you do is you sub in, so you're asked to show that it's a solution. You sub it in and you show that the left hand side is equal to the right hand side. So doing that here, we're putting in minus 3, because I'm telling you that's the solution. You get 9 minus 24 plus 15 equals 0, question mark in the middle, but you're asked to show it. So basically 9 and 15 is 24, minus 24, 0 equals 0, done. Right, so how do? You do exactly the same thing over here. You have z squared minus 4z plus 5 equals 0. You're going to sub in instead of z and show that the left hand side is, that it satisfies the equation. Basically the left hand side is equal to the right hand side. So to do this, now you can go off and do your rough work, and you can do 2 plus I multiplied by 2 plus I, and when you work that out you'll end up getting whatever. I'm going to go square the first, square the last. I multiplied by I is I squared. 2 times the first, 2 times 2 is 4, times the last, that's 4i. That's that multiplied out. Just double check it again. Square the first, 2 to be squared is 4. Square the last, I by I is I squared. 2 times the first, which is 2, so that's 2 times 2 is 4, times the last, 4 times I is 4i. Minus 4 times 2 is minus 8. Minus 4 by I is minus 4i. And you've got a plus 5 over there. So tidying up a bit now, as much as we can. We have an I squared there. I'll just leave him there for a second. We have a 4i minus 4i, cancel. We have 4 and 5 is 9. 9 minus 8 is 9 minus 8 is 1. And we all know then that one of the fundamental things of complex numbers is that I squared is equal to minus 1. And that's going to be minus 1 plus 1 is equal to 0. And of course 2 then minus 1 plus 1 is 0 equals 0. So therefore 2 plus I is a solution. But we already knew that because the question said show that it's a solution.